All right, should we do this, Jeremy? I don't
Let's
know.
do it.
I kind of don't want it to end, except for the fact that we've been live streaming for 12 hours.
Follow the it's follow the sun one time, not follow the sun forever. We can't. You don't want to see sunset from the wrong side.
Excellent. Well, again, we appreciate everybody coming and joining us in for Proximity, our anniversary momentum event and user conference. Do we have Andy Schwabecker coming in from Japan yet, or we've got a
I've
little
seen
bit?
him pop up in the green room 2 times, but I think third is probably the charm.
Come on. Well, Andy gave a talk at our user conference a couple of years ago, and he always comes up with great titles. So I believe this one is No Wallet, No Cash, No Phone, No Problem. Scaling facial recognition at the edge in Japan. Last talk he gave was the use case, the killer use case for 5G is 6G.
Oh, okay.
Yeah, very meta there.
I'm curious if they've been able to solve the problem that you have.
Which problem do I have?
You have a twin, and oftentimes the facial recognition with the twin is free money for either the less reputable twin.
Hey, Andy.
Hi, guys.
How's it going?
Good to see you today. Good.
You were right on time because we were asking the most important question for the leader of the Japan computer vision technology business, which is, can your technology change the, check and not give Jacob, a free checkout when I'm trying to buy something at the mini mart? Can it happen?
So that is actually in my talk. The answer to this exact question. So is in my talk. Now there's two things. One is he wearing a face mask? Is he wearing a face mask, or is it no face mask?
I think no face mask right now. He's in Vermont. They don't need face masks because there's no people.
Yeah, no face mask, no problem.
Okay. Well, listen, if you wouldn't mind, you are the last session of our 12-hour live stream of Proximity, which is us celebrating 1 year here at Equinix. First and foremost, could you introduce yourself? And then we have a question we want to ask you.
All right. Well, my name's Andy, and I'm the CEO of a company called Japan Computer Vision Corporation. And that is a mouthful, but I will explain quite a lot about the company and why it's named that way. So this is just a brief introduction. So I joined SoftBank actually about 7 years ago. I was in the Bay Area. I was in the infrastructure space. I was actually competing with Zach a long time ago. And I've been in data centers and cloud computing for most of my career. And then kind of shift gears in 2014 and started looking at things as an investor and bringing new technology from the US to Japan. And long story short, now I'm running an AI company here in Tokyo. And we are a spin out of SoftBank. We raised $26 million in 2019. And we're just totally focused on bringing face recognition technology to the market here in Japan. And I'll just start off with a couple of the products we've got.
But can we interrupt you? We want to ask
please interrupt me.
I know you're ready to go, but we want to ask you an icebreaker, totally random question.
Okay.
All right. Jeremy's been queuing it up, so.
There's actually 3 icebreaker questions.
3 icebreakers. Oh my God.
It's mother's maiden name, favorite. What was your first pet's name, and then the street that. Seriously.
It sounds like you want to download my income taxes for the IRS.
Why don't you it was worth a shot though. If you were to keep any mythical beast as a pet, which one would that be?
Any mythical beast as a pet?
Unicorns, Pegasus, Cerberus, the 3-headed dog that guards the gates of hell. Anything.
Wow, that's a tough one. I think having a unicorn in your backyard would be kind of cool. I think that would be kind of cool.
Plus, we know you do unicorn farming.
What about the Monty Python movie with the rabbit that they have a killer attack rabbit? That's what I want, is a killer bunny rabbit like that that keep me safe at night. I wouldn't worry about anything. That's my answer to your icebreaker.
Well, we're going to let you go into presentation mode, Andy, and do the dig. So tell us all about what's going on there in Japan.
Great. Okay. So we sell a couple products we've built that are around building access. So entering the building with your face, actually. And then the building access product, which was kind of the icebreaker for face recognition, brought us in around the time of coronavirus to a market involving taking the body temperature and doing thermography on the human body to understand what the body temperature is. And then we also have a set of SDKs that we're selling and providing to developers to build applications to do one-to-one and one-to-end face recognition, searching databases of faces, and then doing that in the cloud and locally at the edge. And we have some face recognition SDKs that are used widely. And we'll show some real-world examples of how those are being used actually in Japan and in the United States. And also attribute analysis is something we can do. So understanding if somebody coming into your restaurant is happy or sad after their customer experience without sending them a survey, looking at the facial expression. If they're smiling, maybe they had a happy experience. If they're sad, maybe they're frustrated with the customer service. So we can do this kind of attribute analysis in an ethical way. So we don't have any way of looking at things like race or political affiliation, those types of things. We just look at the facial expression and we can guess about the age and the gender, those types of things. And then also AR has been a big use case for us to do human gesture identification to understand thumbs up, thumbs down. And that's been used in some interesting ways that we'll show you later in this presentation. But it's all a mix of hardware and software in the cloud and at the edge. And it's been a fantastic ride for us to bring face recognition as kind of a mainstream technology with something that can happen outside of just your iPhone, face unlock. And the whole idea, we see this technology as a key to kind of make actually everyday life better, especially customer service applications using these computer vision and AI technologies. So I always think about the Four Seasons Hotel versus the 7-Eleven or convenience store. So when you go to the Four Seasons Hotel, people treat you very nicely, because you're spending a lot of money and they invest a lot in the customer service. And that's really about knowing the customer and understanding the customer. And so face recognition is a way we can actually create a world where it's possible to know the customer much better and treat them much better based on the information that you have for them. And there's been a lot of maybe controversy about this topic. People think this is an invasion of their privacy and so forth. But I think, if you go to a place and people remember who you are and remember what you like for breakfast, maybe at a hotel when you're getting breakfast there in the morning, in some aspects of the world, we call that hospitality. So we think that this technology can actually improve hospitality, or as we call it in Japan, omotenashi, which is treating customer as if they were a god. And so that's the idea here. We're injecting these systems into all kinds of retail and hospitality systems all over the world. So let's start with just the first kind of video to give you guys an idea of how this technology works. So this is, like I said, the first use case we had, which was just opening the door. And so this is our face recognition terminal, and the algorithm works very fast. We can do the whole face recognition process in about 200 milliseconds. And so that means if you've got a building you're going in every day, you can get in very, very quickly, and you don't need to bring your ID card. It's a little more secure than the ID card because, of course, we're using your face, and you can't give your face to somebody else to use. And that's the next point. So face recognition is nothing without the capability to do what we call anti-spoofing. So if you take a photo of yourself and you point the photo at a face recognition system, it should always do this. It should always tell you, hey, this is a non-living attack or a liveness event. So we always have to verify that the person who's coming through the face recognition system is in fact a real person, and it's not a photo of a person. So that's just a brief synopsis of how we started in this space and how we got going in the market. And so our core product, new one, is called Sense Thunder, and this product is in fact a combination of AI thermography. So we have basically an IR thermal camera, and we combine that with the face recognition system to do body temperature analysis and face recognition together. And in the world with the coronavirus, when we launched this last February, we had quite a lot of uptake in the market here in Japan. And so we have a cloud system called SenseLink. We store all the face information, access information, and body temperature information there. And this allows our customers to create kind of safe workplace environments, safe office environments, safe restaurants, that kind of thing. So it's currently the #1 selling AI thermography product in Japan. We've sold many of these products. They're quite common, I think, in Asia, but maybe not so in the US. So this is kind of the core product. So our mission here was to build the #1 computer vision platform, at least in this market in Japan. We've got about 13,000 of these devices installed in retail locations. And we know now that many people pass through them every day. So we've launched a new AI cloud platform to run the services supporting the face recognition and kind of creating access management solutions based on this product and new applications to do many things in the Equinix cloud and also AWS. And so we've got this platform now and we're building lots of applications. Let me show you what this looks like. So it's a combination of edge devices. So we have these 3 devices for building access and AI thermography and one for video analytics. And we combine that with an IoT device management and access management platform. So we control who can come in the building at what time, integrate with HR systems, time tracking systems, all kinds of things, and then actually manage all these IoT devices attached to the cloud. So we have to do remote update and, security checks, lots of things. And then we have an identity management system, which is sort of like, if you can think of it as kind of an active directory for your face. So this system is basically an identity source. You can bring in whatever one you want and then associate the face with it. And then you can use that as an identity source to do authentication for all types of activities using your face. And then the video analytics allows us to stream video from surveillance cameras, from IP cameras or web cameras, and then do all kinds of analysis on the video to understand how we can convert this kind of unstructured data to structured data, get analytics out of the video, and trigger lots of real-time things. And so we have partners now building all kinds of applications on top of this computer vision platform. One of the most exciting ones is face-based payment. So, if you don't have your wallet with you, you don't have your phone, you don't have cash, no problem. You can pay with your face with quite a bit of accuracy. So this has been integrated into point of sale systems. And one of the best use cases we found is actually order recall. So if you've ever gone to a restaurant and maybe you have your family with you, you've got a bunch of people and you all want to order dinner at, like, say, a Wendy's or a In-N-Out Burger, you've got to remember what everybody wants in their hamburger: onions, no onions, pickles, ketchup, etc. And then you've got to argue with your kids, what do they really want, out large soda, etc. You don't want that. So it's a lot easier just to remember based on your face what your last order was. And then you can just say, yes, I'd like to have the same thing I had last time. So this has really improved efficiency in restaurants, and coupons and rewards are a big part of this as well. So a lot of these e-commerce ideas with face recognition, with e-commerce you had, of course, the website cookie, and they had logged in, but offline you don't have that. So if you can use the face to kind of link and connect those worlds, there's a whole world of new applications that are possible offline. So that's just a summary of our platform and the types of applications that have been created with it. So let me go into the next section here, and I won't take too much time. I know it's a fairly technical audience, I think, here. I want to explain how face recognition systems really work. So there are 3 steps. The first step is to capture the face image. So we've got to identify, if it's coming from video, the frames of the video that contain the subject and their facial features. Then we've got to apply an anti-spoofing algorithm, because no face recognition system works if you can hold up a photograph of somebody and spoof the system. So we have to ensure the video or image is live and it's not spoofed. And so this is where a lot of the AI comes in, and I'll explain how this works a little bit later. And then the next step is to actually do the face recognition to verify, this is Zach coming to the In-N-Out Burger, or this is maybe Andy walking into the Four Seasons Hotel. So the idea was we compare the image with a database of portraits, and we can ascertain whether or not the image presented in the video is in fact somebody who exists in the database. So that's the overview of the system. And then this is actually how it works. These are the kind of the technical details. So what we're really doing is we're converting video and images, which are sort of unstructured data, to actual structured data. And how we do that is we run a pre-processing system where we detect where in the video the face exists. To do that, we use a AI face detection model, and that's finding the face in the video frame and then locking onto it and tracking it with the face tracker. And from there, we do feature extraction. So once we know where the face is, we identify landmarks, which are your nose, your ears, your eyes, your mouth, and we have thousands of those throughout the face. We extract those areas of the face as features. We look at their geometry, the distance between them. So it's not really about skin color, it's more about face geometry. And then the idea is we can create a feature vector after we've extracted, and then we can compare and search against that vector in a large database of faces. So that's how the face recognition system is put together and how the algorithm really works. We're searching vectors of features across a database. And that database today, the biggest one we've seen is about 10 million images. And it's actually working quite well. We can search it in less than a second. And that's actually a metro system in China that's using this type of technology. The other thing we can do is we can just compare once we've got the vector out of the database. Once we've identified, oh, we think this is Andy, we can do a detailed comparison, and that can take more time to actually verify, use face verification to verify the person is who we think they are. And then anti-spoofing is done using two types of AI models. One is a monocular model. So we're using just a single camera, and we're using an AI model to determine, is this a real person or a photograph of a person? And there's an AI model that's been trained to do that with large set of labeled data. And then we also have a binocular model, which is used to take two cameras, maybe an RGB camera and an IR camera, where we can get some depth calculation, and then the model is trained much more accurately because it has the depth to understand, is this a real or fake person? And so that's a very important part of the system. So this is kind of how it all comes together. You've got to extract these areas of the video, pull out the landmarks, identify the features, and then compare the features. And that's how our system works. So once you've done all that, and this is the great intro question Zach had, which is, can you make sure that we're not misidentifying anybody? And to do this, we use something called the ROC curve, which is really common in AI algorithms. It's the way AI algorithms are quite, mostly evaluated. And it stands for the receive operator characteristic. And we look at two elements. We look at the false acceptance rate, which is the identifying idea of maybe we get Jacob, who is Zach's brother. We compare the two of them, and we find out that, we misidentified Zach as Jacob because they look alike. They're twins, perhaps. So that false acceptance is unacceptable in a face recognition system, because that could result in you being misidentified. So as you can see, our system, from this test we did, this was just 100,000 images, but we have about a 0% FAR at a 90% threshold. So we look at this threshold value in the ROC curve to find out where the sweet spot in the system is for whatever data set we're looking at. And then the other thing we have is, of course, the false recognition rate, which means we've got Zach standing in front of the camera and Zach in the portrait database, but for whatever reason, we can't identify Zach. And so this is how we test the system to ensure that it's going to work correctly in a large population before we roll it out for something like payments. The algorithm has to be thoroughly tested and evaluated. And of course, no AI is perfect, but as you can see, we're pretty happy with the results we've got with this algorithm. So I want to talk a little bit about why we need edge computing to do this, why it has been an important part of what we're doing. So we hit this thing, as you know, with the 4G era called the latency wall. And, we have, I think, 30 milliseconds, sort of the average of, round trip time from a package come off your mobile phone to hit, a data center. And so that gives you a throughput at maximum of about 39 megabits. If you look at the TCP connection calculator, because of laws of physics and TCP, et cetera. So this latency wall is kind of a big deal, because if you're trying to correlate video of somebody live to understand if it's real or not, and then search a large database of faces in the cloud and do a bunch of operations in the cloud, all those things have to work together, and this latency really adds up and slows things down. And then we can't really make real-time building entry systems, real-time payment services, we have to put the processing at the edge. And that's the whole idea of solving the data gravity challenge, which Zach and Equinix team have been trying to do for a long time by opening up lots of data centers all over the world. And the idea in the 4G era, the data kind of went to the cloud, and now with the new technology we have from Equinix, the idea is to bring the cloud actually to the data. And you can see this is kind of the difference between e-commerce and what Amazon's doing with their automated grocery stores. We want to do the same thing with face recognition, actually bring the cloud infrastructure closer to where the users are so we can make these kinds of retail systems work. So let's go through a few real examples. So first one I'd like to show you is actually a live restaurant point of sale system in Los Angeles. This is a restaurant. If you've been to LA, you might have been here. Users can come in, they can actually register using a QR code for the system. And this is using a company called Pop ID. It's one of our partners implementing the face recognition system on our SDK. And so the customer will register once they come to the restaurant, if they're coming there for the first time, and then top up a cloud wallet. And then once they've topped up the wallet, they can basically pay with their face when they make an order through this restaurant point of sale system, and use a hand gesture to make a tip, maybe a shaka for 20% or a thumbs up for 10%, kind of streamline the whole process, make it non-contact. You don't have to touch any kind of a kiosk, and you can pay for your order at the restaurant. This is another restaurant in Los Angeles, same type of concept. User comes in, it's all integrated with the restaurant point of sale system, and they key in the amount, and then the customer can actually just pay with their face. They have to pull down their face mask in this case, but wait and see what we're going to do in the future. We won't have to do that much longer. So for building access, this is another example of what we did with the technology here in Tokyo. So SoftBank, we moved our headquarters to this new building in Takashiba, which is just across the street from where our old building was. It's a 40-story office building in central Tokyo. And the challenge here was you've got so many people coming out in and out of this building, thousands of employees, and it's a mixed use. It's got a shopping mall downstairs, kind of a WeWork in the middle, and lots of offices, lots of people coming into the building. So if we can use face recognition to get people in and out of the building faster, just be a lot more convenient and a lot more secure. And then also we had the coronavirus, so we want to integrate the body temperature with the building infrastructure. So this is our face recognition system deployed at the security gate. We have about 500 face recognition terminals all over the building. So if you're going to your office, you're trying to access the cafeteria, et cetera, you don't need any kind of a badge. And we integrate with the elevator system, so the elevator arrives, takes you to the right floor based on who you are when you come in. So that's an example of actually a live building in Tokyo using the face recognition system. And then in healthcare, actually today, JCV, we've got about 2,500 customers in Japan, and about 1,000 of those are hospitals. And hospitals have been a great customer for us. And this is an example of what we've done with AI thermography in the hospital reception. So we're using the thermography system and face recognition to basically enable quick reception in the hospital. And we've got this deployed in hospitals all over Japan. So that's a summary, I think, of the face recognition technology, who we are at JCV, and hopefully give you some not just technical slides, but real world use cases so you can see actually this technology is kind of here today and it's working. And I'd just like to show you one more interesting thing we're doing at the edge. This is the edge-based AI processing of video. So we had many customers come to us and say they had lots of surveillance cameras, but they wanted to basically extract the features from the video locally at the edge. And at first we thought, well, we'll just build a big data center and we'll run a bunch of NVIDIA GPUs and we will process all the video as it comes in. And then we realized that probably won't work. It'd be too slow and too expensive. So what we've done is we released a small edge box that's got a CPU and a TPU. And the TPU is designed to run the face recognition neural network directly on the silicon. So it's got instructions that optimize the neural network, and it runs there. And so we can run it on 4 or 8 1080p video streams and do face recognition on the video dynamically from kind of in real time from a database of 300,000 faces that can be stored locally. And we store, again, the feature vectors locally, not the face images. And then we can extract the body attributes. And all this runs in about 20 watts of power. So it's very, very low power consumption, lightweight design, and plugs in the network and standard Ethernet, and then attaches to our cloud system. And this is kind of a video showing how the whole system works together. So this is basically, you can use it to identify people. You can identify maybe they're a stranger, or somebody you want to maybe they're somebody who's stolen from the location. You want to prevent them from doing that again, or notify somebody when they're there. So we put the system together, and it also integrates with our cloud product, which is called SenseLink. So you can keep the identities and access management there. And sorry, this video is in Japanese, but you get the idea. The edge box runs at the edge, plugs into the surveillance video, and then connects to the cloud to manage all the identities and access management. And the customers can, of course, manage the system. From PC, you can upload photographs and then say, okay, this is a returning customer. He's Zach, and he really likes In-N-Out Burger, et cetera. So you can have these kind of attributes extracted with him, and then plug it directly into the surveillance video without very quickly modifying anything on site. So that's it. That's the intro. That's who JCV is. This is the technology we're delivering to the market in Japan. I'd like to thank you all very much for the opportunity to speak to you here today. And that's it. Thank you.
Dude, so that's incredible progress, man. I remember when a couple years ago you were just telling me about how this was starting to emerge, but this industry of facial recognition, completely changed with this pandemic. I mean, is it yes, no, or is it just a right alignment with the technology curve and society's needs, or?
Yeah, well, when we started this discussion, it was a tremendous political challenge to make people think that people are going to deploy these kinds of face recognition systems. But with the coronavirus, I think it was, accelerating many things. It accelerated video conferencing and work from home, and all these technologies, e-commerce, that kind of thing, and even face recognition just came along for the ride. So we're quite lucky that we were able to take the opportunity to make it happen at this time. Yeah.
Yeah, well, that's incredible what you guys have done. And our audience is asking, are you partnering with SenseTime?
Yeah, very much so. So they're our technology partner. We work very closely with them. They're probably the world leaders in computer vision and AI. They've got about 4,000 employees, and they're leading the research in face recognition in this area. Yeah, so we're definitely working with them. Awesome.
And how are you guys dealing? I know you wrote some papers I read early on about how to deal with the concept of identity and having some control over identity in society. Have you, how has that evolved, and how are you seeing that work with, both regulation and also just practice?
Well, in the U.S., basically to do what we're talking about is illegal effectively in many states. It's really quite illegal. So I don't think the market in the U.S. is ready to go. All of the systems we showed you in the U.S. are totally opt-in. And opt-in, I mean, it's a requirement. You've got to opt in. Nobody wants to be misidentified or identified without giving explicit consent to do so. But that said, people are willing to work with opt-in systems, and they're willing to opt in to use these kind of systems, just for the convenience of doing so. And so we found that, hey, it's possible to do, and it's just the beginning. And I don't know about you, but I use the Face ID on my iPhone to unlock my iPhone every day. And, I'm sure Facebook knows where I am, and Instagram knows what kind of music my wife listens to, and they can market to me using all kinds of profile and identity. So I don't think people really are happy about how this has gone online. And safeguards have to be put in place. And we're starting to see that online. I think we saw some interesting announcements from Google yesterday about pulling out of the profiling business, et cetera. Yep. So this type of tracking and targeting that's happened online is really not what we're talking about. This is not an advertising solution. This is just a way to kind of extend the hospitality in these environments. So we'll just start there and see how it goes with an ethical approach to the idea. I think if you look at the 1984 scenario, which is kind of the elephant in the room, this idea of dystopia and so forth that Orwell described, it's inevitable. I think that we've gone towards that way with the internet, and we have great organizations like the EFF, et cetera, that are fighting every day for our rights to privacy online. And there's no reason that we shouldn't extend those rights offline as well. I think offline they're just as relevant. But this is targeted at basically making restaurants more efficient. It's targeted really at efficiency in hospitality. So, I think like I said, you go to the Four Seasons Hotel, they treat you nice. We call it hospitality, not privacy invasion.
And first you have to give them your name, right? You have to do that. And I think that's really an interesting point that you're making, Andy, which is an online scenario. A lot of places, even though now we're starting to see like, oh, do you agree to this cookie or whatever? But like, you have to give explicit permission in those restaurants you walk in. You're agreeing to like have this value exchange, which you are aware of. When in a lot of cases, I think online, that might be not well understood.
I agree. Yeah, I think these opt-in systems are something we're going to have to do. And we've got them integrated kind of the user interface now. And then we'd very much love to hear the feedback of, the audience and today, what they think about this. And certainly, if you go to Los Angeles and use these systems in Los Angeles, please let us know your thoughts. We're very open to ideas on how to solve the identity issue and make this work in a humane and ethical way.
Awesome,
so yeah,
Andy.
Thank you very much for the opportunity, and congratulations to all of you. Thank you very much.
Andy, it's
Thanks
been
for
great
coming.
having you, and we'll let you go on with your day over there in Japan. I just want to say it's so cool for me to celebrate 1 year in. Andy was one of the reasons. He backed us over at SoftBank years ago and was on the Equinix advisory board. One of the main reasons why we know so many great friends here at Equinix. So my friend, I miss you. Hope your family's doing well, and thanks for spending the evening with us.
Likewise. Thank you very much. Take care, guys. Bye-bye.
All right. Bye, Andy. Well, Jeremy, that's a wrap. Like, how about this? We had an incredible day. I don't even think I can remember all the awesome sessions, but anything stand out in your mind?
So the theme of video gaming, moving from a box that's in your house to a box that's in a cooled and networked data center somewhere, and you have the iPad or the Raspberry Pi or the whatever that client that sits right in front of you that a controller can connect to, which is an interesting thing. But I think that's where a lot is going, is not necessarily having the computer right next to you, but having it whenever you need it.
Cool. Well, I personally was inspired by the decentralized broadband networks. I think that's incredible. I missed Cody Hill's presentation on Google, but I can't wait to watch it in replay. But overall, I can't even list the number of amazing participants. So we're going to call it a day. It's been a long one. We so appreciate you coming to Proximity. We hope that we're going to do this again. Thank you so much. Retweet it, show. We're going to get you the videos. But everybody, have a good night, and thanks for joining us. Proximity.